Hello everyone, I am Pawan Kumar Sak, PhD scholar from IIT Kanpur. I am the TA for the course of Elements of Solar Energy Conversion. In the last class, I have discussed the sign convention for the different angles like latitude angle, hour angle, azimuth angle, declination angle. Also, I have started the topic shading in the last class where I have solved one problem. So today I will show you more problems on the shading, and after that, if the time allows, then we will see that how can we measure the solar radiation. Okay, so I will continue this session by discussing the shading. Okay, so first, what is shading? So shading is when the object, any object, it may be like any buildings, okay, or any tree. If the object comes in between sun ray and the collector, okay, collector or receiver. Suppose this is my collector and this is the sun ray. If there will be not any object, then this sun ray will come to the directly, okay. But if there is any object in between the sun ray and the object like this tree, then there will be shading, okay. So this is the basic concept for the shading. Now, I will show you that what type of problems you may face in the topic shading. Okay. So mainly there are three different types of problem that you have to deal in the shading. Okay. The first problem is that I have discussed earlier is similar, like when a building or tree or any object comes in between the sun ray and the receiver or collector. Okay. This type of problem mainly solved by the sun path diagram. I will show. I have also shown this in the last class, but today again I will solve one more problem on this topic. Okay. In the sun path diagram, there are some fixed parameters like latitude angle, declination angle, hour angle. These parameters has been fixed in the sun path diagram, whereas you will see that the variables will be altitude angle and the azimuth angle. Okay. The second problem that you will see is like shading windows by the overhangs. That you have this type of problem you have seen in your home, like where suppose this is our window and there is an overhang. Okay, then you will see that at some time there will be shading on this window. So at what time and how much shading will be happen on this window, that we will see. Okay. Next, the third problem is like shading of the collectors by its preceding row of collector. Okay. So The third problem is like when you have number of rows of collectors. Okay, then what will happen that at some time the shading of the preceding array, that is like suppose this one is our first row, then at some time there will be shading on this panel. Okay, so this will be the shading, that how much will be shading, that we will see by a problem. Okay, so now I will move to the first problem. The first problem is given. It is proposed to install a solar collector at a level 4 meter above the ground. A rectangular building 30 meter height is located 45 meter to the south, has its long dimension on an east-west axis and has dimensions shown in the diagram. The latitude is 45 degree. Diagram this building on the solar position plot to show the times of day and year when it would set the proposed collector. So you will see that here the latitude angle is fixed. It is given in the problem that L is 45 degree. Okay, and this is the figure that we are talking about. This is the building, and here is the position of the proposed collector. Okay, so now I will solve this problem. So to solve this problem, what we need to calculate the altitude angle and the azimuth angle, that is AZ. Okay, so to draw this we have to take randomly some points on of this building to solve the problem. Let's I have taken the point like A, C at the rightmost position, B on the leftmost position. Let me take one more point. Suppose I am taking one more point D, and this point is 20 meter. So these points I can take many number of points as per my choice. What will be the effect or why I am taking one more point D, that I will show you through the figure. Okay, so first I will calculate these altitude angle and azimuth angle for the rightmost point, that is for C. Okay, so for C, so first I am drawing the top view for this collector. Okay, so this is our C point. This one is A, this one is B. Now this is the distance 45 meter away the building is from proposed collector. Okay, and the AC distance is given as 8 meter. Okay, now you will see that if I in the problem it is given that north is upward, so the this direction will be towards southward. Okay, if I will connect this collector that I am representing as O to the point C. Okay, then this line OC, the angle makes it with the OA. OA is in the south direction. Okay, so this angle will be azimuth angle. Okay, so for point C we can calculate azimuth angle. So it will we can use the tan rule, that is tan AZ equal to AC divided by OA. It will be 8 divided by 45. When you will solve, you will find that AZ comes out to be 10 degree. Okay, now you will see that in the last class I have told you that we take azimuth angle in the east direction as negative. Okay, whereas in the west direction we will take it as positive. So the C point is in towards the east direction. Okay, so we will take this azimuth angle as negative minus 10. Okay, now second, now we have to calculate the altitude angle. So to show you the altitude angle, I will sketch a three-dimensional view. I will try. Okay, the building height is given as 30 meter. Okay, this 30 meter is the height of the building. Suppose this is the building height. Okay, Now this point is C. Okay. Also, it is given in the problem that the collector is at a level of 4 meter. Okay. So this height is given as 4 meter. Okay. Now, this one I have taken at O. Now, suppose this is our ground plane. This one. Okay. I am taking the point with dash on the horizontal or sorry ground plane. Okay. So this one is C dash. Now you will see that this this O dash C dash. Okay, this will be the distance between the proposed collector and the building. Okay, so if you will see it from the side view, then you will find that if this one is our C dash, this is our C, and the height between the height of the building is given 30 meter. Okay, and what you will see that this one is our collector, that is O, and the height from the ground, this is the ground. Okay, and this O dash C dash points is on the ground. Okay, uh, okay, fine. And the height, I think there is some problem in the connection, so let me fix it. Okay, I think it's fine. Yeah, now it's fine. So let's go. uh, so now what we have to calculate, we have to calculate the altitude angle. So if you will connect this OC, okay, and if you will project it on the horizontal plane, this will be the horizontal plane. So this angle will be altitude angle. Now you have, I expect that you have already gone through all the lectures that has been delivered by the professor. Then you will be aware that the altitude angle is the uh, angle between the sun ray and its projection on the horizontal plane. Okay, so this angle alpha we have to calculate. Then if this dimension, this dimension will be 30 minus, and this one is 4 meter. Okay, so this one will be 26 meter. So now you can calculate the alpha altitude angle. That will be alpha is equal to tan inverse. Suppose give some this name to this point C double prime. Okay, then this alpha will be tan inverse C double prime divided by C double prime O. Okay, and if you will put these values, then you will find that it will comes out to be 26 divided by this OC double prime, or we can say O dash C dash, that we don't know it, but in the problem it is given that this OA is 45. Okay, if I will project it, it will be A dash on the ground. Okay, then you will see that this angle O dash A dash C dash. Okay, this angle is 90 degree. O dash A dash is given as 45 meter, and this A dash C dash is given as 8 meter. Okay, so you can easily find that O dash C dash, it will be under root of O dash A dash square plus this A dash C dash, A prime C prime, or we can. Okay, so when you will put these values, you will find that it comes out to be O prime C prime is equal to 45.7 meter. And when you will put this value in this, then you will get the alpha value at 29.63. Okay, so for C you have calculated both the angles, altitude angle and azimuth, surface azimuth angle. Okay, so suppose this one is alpha, then this value is 29.63. If this is azimuth angle AZ, then it will be minus 10 degree. Okay, so similar we have to do the calculation for the remaining points, that is A, D and B. Okay, so now I will do this for the point A, for A. Okay, for A, if we will see from the top, this one is our object O, sorry, collector O. This is the point this is the point A, and this is the distance 45 meter. Now you will see that this A point is already in the south direction. So what does that mean? That the azimuth angle for the point A will be 0. Okay. Now we have to calculate only the altitude angle. So for to calculate the altitude angle, we will need the side view. Okay. This is the building. This is our A point. This is our A prime. This one is our collector O. This one is O prime. This angle will be the altitude angle that we are trying to find. Okay. This height of the building is given as 30 meter total. Okay, this one is given 4 meters, so this one will be 26 meter. The distance between the A prime and O prime is given directly in the problem as 45 meter. Okay, so when you will solve this alpha, you will find that alpha is equal to tan inverse A. If I am giving this as the A double prime, then this tan inverse A double prime O divided by, sorry, it will be A double prime divided by A double prime O. Okay, when you will put these values as 26 divided by 45, you will find that alpha comes out to be nearly 30 degree. Okay, so now you have both the altitude and azimuth angle for the A point. Okay, alpha and Az. The azimuth angle value is 0 and alpha is 30 degree. Okay, now I will solve it for point B. Okay, so B is at the leftmost position, and this is given as 45 meter. This distance is given as 52 meter. So you will find this angle will be the azimuth angle. Okay, so you can find easily that Az will be tan inverse of 52 divided by 45. Okay, when you will solve, you will find that this angle comes out to be 49.13 degree. Okay, now to calculate the altitude angle, again we have required the side view. So this is our 4 meter above collector O. This one is our point B, 30 meter above from the ground. Okay, when you will connect this and project it on in the horizontal, then this angle will be altitude angle. So this is the distance that we know is 26 meter, and this distance, suppose this one is B dash, this one is O dash, B double prime. We don't know the distance between the B dash O dash. Okay, so we have to calculate from the above figure. You can see that this, sorry, this OV, this will be equal to O prime B prime. Okay, and it will be equal to under root of 52 square plus 45 square. When you will solve, you will find that this value comes out to be 68.77 meters. Okay, now you can easily get the altitude angle, that will be tan inverse of 26 divided by this distance O prime B prime, that is 68.77. Okay, when you will solve, you will find that this value comes out to be 20.71 degree. Now for B, I have also calculated both the altitude angle and azimuth angle, that is 20.71, and this one is 49.13 degree. Okay, similarly you can calculate both the altitude and the azimuth angle for point D. Okay, so I'm not doing the calculation again. I have calculated these values, and it has been found that alpha comes out to be 27.83 degree, and the azimuth angle found to be 23.96 degree. Okay, Now you have all the altitude and azimuth angle. Now you have to see on these points on the sun path diagram. So this is our sun path diagram. It will be the latitude angle. Okay, so I have told you that some parameters have been fixed on the sun path diagram, like this sun path diagram is only for this latitude, that is plus minus 45 degree, that is north 45 degree or south 45 degree. Okay, this solar altitude angle, this will be the alpha, and this one is solar azimuth angle, that I have represented as AZ. Okay, so now if you will plot, now you will see that in the x direction solar azimuth angle is in the x direction, whereas altitude angle in the y direction. Okay, now I'm writing these points again to for simplicity. 20.71. Okay, so this is our C point, this is our A point, this one is B point, and this one is D point. Now what do we have to do? We have to plot all these 4 points on the sun path diagram. Okay, so let's suppose C point is 29.63 degree alpha and minus 10 degree azimuth angle. So when you will go that minus 10 degree on this axis, minus 10 in the left word. Okay, and mm, will go to the alpha equal to 29.63. You will find this point lies somewhere here. Okay, so this point is our C point. Okay, when you will plot thus azimuth angle for this point A is 0. On this 0 point you will plot this A point. Okay, so this one is our A point. Similarly, you can plot both these points B and D. This point will be our D and this point will be our B. Okay, when you will connect these points you will find some curve. Okay, and when you will project this in the x direction, whatever comes below, okay, this portion will, this days and times that you are able to see in like 16 Feb, 14 November and 17 Jan, 10 December, like these days, and you are getting that time like it is given noon. Okay, this line is for noon, this one is 11 a.m. So let's say this is around 11 a.m. 30 minutes. Okay, so for these days, okay, that you are seeing these days and these hours, these are our hours. Okay, so this all the day for all the hours in these days will be shaded. Okay, so that's all the question is asking about. Now I will as I have taken I have shown you that I have taken one more point D. Now what was the purpose to take this point D? Let's say your domain is higher, okay, and you are taking very few points, then what will happen? If you will connect, suppose your A point comes here and your B points come here, and you have taken only 2 points in a direction, then you don't know the curvature of this curve. To know the curvature, that how it's varying, okay, to see the curvature we have taken more number of points. So that was the purpose to take one more point. Okay, so this is the area that will be shaded. Okay, so now let's move to the next problem. Before going to the next problem, I would like to introduce one angle, that is profile angle. Okay, what does this profile angle mean? That I will try to show you. Okay, let's say this is an overhang. Okay, and here comes our window. Okay, suppose this is our sun ray that is coming to this point. Okay, let me draw the horizontal plane. So this is the horizontal plane that is perpendicular to this window. Okay, now you will see that if we project this sun ray on the horizontal plane. Okay, suppose this is the sun ray falling on a point C, then this and this point is A, then this BC. Okay, what is this BC? This BC is the projection of sun ray on the horizontal plane. Okay, similarly what we can do that if we try to project this sun ray on the vertical plane, this is the vertical plane that I'm talking about. Okay, then let's say that this AD is the projection of sun ray on a vertical plane. That is perpendicular to the window. Can anyone tell me that what will be this angle that is making between the sun ray and the projection on the horizontal plane? Okay, so this angle will be altitude angle, that is alpha, that I have told you. Okay, now this angle, between AD and BC, what is this? This is the angle between the projection of the sun ray on the vertical plane with the horizontal axis. This is our profile angle. Okay, so this is nothing, just a projection of altitude angle on the vertical plane that is also perpendicular to the window. Okay, so that I want to show you through the figure. Now what I will try to establish a relation between this profile angle and altitude angle. Okay, let's say this is the south direction. Then what will happen? This BC is the projection of sun ray. So this angle, that projection of the sun ray on the horizontal plane makes with the south direction, is called the solar azimuth angle, that is AZ. Okay, now if I will draw the vertical direction of this plane of this window, then this is the vertical direction of the window. Okay, now this direction makes the angle with the south direction, it's called the surface azimuth angle, that is AZS. Now we can easily see that this angle will be our AZ minus AZS. Okay. Now what we have to calculate? We have to calculate the relation between profile angle and altitude angle. So now I will solve this. So first let's take in triangle ABD. Okay. In ABD you can write that tan P is equal to AB divided by BD. Okay. Now if I will from the figure you can see that this angle, that is AZ minus AZ, and this angle CBD will be equal. Why? Because this plane is also a vertical plane that is perpendicular to the window plane. So this angle also will be AZ minus AZS. Okay. So if I will take the triangle BDC, okay, then you can write that cos AZ minus AZS will be equal to BD divided by BC. Okay. And from here you can calculate that BD comes out to be BC cos AZ minus AZS. Okay. Now if you will see in triangle ABC, okay, in triangle ABC you can write that tan alpha will be equal to AB divided by BC. From here you can find that AB is equal to BC tan alpha. Let's say this is equation 1, this one is equation 2, this one is equation 3. Then place the value of AB and BD in equation 1. Then you will find that this tan P is equal to BC tan alpha divided by BC cos AZ minus AZS. Okay. So BC will be cancelled out and you will find the relation between the profile angle and altitude angle. That comes out to be tan P equal to tan alpha cos AZ minus AZS. Okay. Okay. So now we will look a problem on this formula. Okay. So the second problem, that is an overhang problem. It has been given that an overhang is shown in the figure. In a sunny day, the sun ray makes an angle of 30 degree with the horizontal plane. If the window is south facing and solar azimuth angle is 60 degree, then find whether window will be shaded or not by the overhang. If shaded, then calculate how much fraction of the window will be shaded. And the parameters P, G, H is given in the problem. Okay. So first we have to find out what are the parameters given in the problem. So it has been given that the sun ray makes an angle of 30 degree with the horizontal plane. So what this angle will be? This angle will be altitude angle. Okay. So in the problem, altitude angle is given as 30 degree. Also it has been given that window is south facing. What does that mean? That if the window is south facing, then the surface azimuth angle will be 0. Okay, and the solar azimuth angle is given at 60 degree. From here you can find out that profile angle will be tan P equal to tan alpha divided by cos AZ minus AZS. When you will put these above values, tan 30 divided by cos 60 minus 0, you will find that this profile angle comes out to be 49.1 degree. Okay. Now in the figure you will see that if there will be no shading. Okay, what does that mean? If sun ray is like this, okay, then there will be no shading. Let's say this angle is psi 1. Okay, then you can calculate this angle very easily. how this angle psi 1 will be tan inverse of g. This distance will be g and this distance will be equal to e, that is given in the problem. Okay, and when you will put these values, you will find that psi 1 will be tan inverse of g value and p value is given equal, so it will be 1, and you will solve, then you will find that this psi 1 comes out to be 45 degree. Okay, now I will try to find that what happened at the bottom of this window. Let's, when this sun ray falling on this bottom, okay, then this angle, what will be this angle, then that angle I am going to calculate. Okay, so this psi 2 will be tan inverse of this distance is also h. Okay, so it will be tan inverse of g plus h divided by this distance also will be p. Okay, so tan inverse g is given as 1, h is given as 0.732 divided by 1. When you will solve, then you will find that this psi 2 value comes out to be 60 degree. Okay, now you will see that this profile angle is that we have calculated is 49.1 degree. So also we have calculated psi 1 as 45 and psi 2 is 60 degree. So from the above calculations you can see that this profile angle fall in between these angles. Okay, what does that mean, that it is falling between? It means that the sun ray will be like this. Okay, and this angle will be our profile angle. Okay, this angle is our profile angle, that is small p. Okay, so how much portion will be shaded? This portion will be shaded. Okay, that we have to calculate. So how we will calculate? Now uh, let's say this is point, let's give some name on these points. Okay, so let's, it is a prime, this one is our b, this one is b prime, this one is c, and this one is c prime. So we know the angle, profile angle, that is p, that we have calculated. Okay, and in this triangle a dash, c and c prime, a prime, c prime, c. Okay, so in triangle a prime, c prime, c, what will happen, that this tan p, okay, this tan profile angle, this will be equal to a prime c prime divided by c prime c. Okay, from here we can calculate that this a prime c prime will be equal to tan of 49.1 into c prime. This c prime will be p. Okay, that is given in the problem as 1 meter. Okay, so when you will solve, you will find that this a prime c prime comes out to be 1.1547. Okay, so now you have this value, that is g equal to 1 meter. You have this whole value, that is 1.1547. So this portion, shaded portion, that we can easily calculate. So shaded portion will be 1.1547 minus 1, that will come out to be 1.1547. In the problem it has been asked that how much fraction of the window will be shaded. Okay, so if we want to calculate the fraction, then it will be 0.1547, that is shaded, divided by the total length of the window, that is given as h. Okay, and its value is 0.732. So when you will solve, you will find that this value comes out to be 0.21. Okay, if you want this value in percentage, then it will be around 21%. Okay, it means that 21% of the window is shaded for this altitude angle that is given as 30 degree. Okay, now you can see that this all these calculations depends on the profile angle, and profile angle depends on the altitude angle. So the altitude angle changes with the time. So with the time, this shading will be changed. Okay, so now coming to the next problem, that is based on the multiple row arrays of collectors. Okay, so in the problem it is given that if multiple row array of collectors is arranged as shown in the figure, the collectors are 2.10 meter from top to bottom, that is given this, and are sloped at 60 degree toward the south. So this is the angle that is given in the problem at a time when profile angle is 25 degree. Okay, so in the problem, profile angle is given directly. Then it is asked that estimate the fraction of the area of the collector that will be shaded by the preceding row. Okay, now you will see that this angle is 60 degree. Okay, and the profile angle is given 25 degree. So what will happen? Let's suppose this is our sun ray. Okay, then this angle. Okay, let me make it more straight. Okay, this angle will be our profile angle. Okay, also you can plot here that this angle is our profile angle that is given in the problem as 25 degree. Okay, now how much portion will be shaded? This portion. Okay, this portion will be shaded. Okay, by the preceding row of collector. Suppose this is our A point, this is our A prime, this is B, then this portion A prime, that is shaded by the preceding collector. Okay, that we need to calculate. So how we will approach it? So we will see in this. Just join this line. Okay. Let's say this is our CD. Okay, then you will find, you know this, that this angle is our profile angle, that is B. Okay, now you know that this angle is our 60 degree. Okay, now from the trigonometry you have already know that this angle will be 60 degree, and these are our parallel lines, and this line cuts to two parallel lines, so the angle will be equal. Okay, so this will be 60 degree. Now this P is given as 25 degree. Now this angle, let me take this name as some E. Okay, so this angle, let me give some name. I am giving it as X. Okay, so what will be this angle X? Okay, that we can easily calculate. This X will be equal to 180 minus this 60 degree minus this profile angle, that is 25 degree. When you will solve, this X value comes out to be 95 degree. Okay, now we have this value X. Okay, uh, also you will see that this DV and this AC line are parallel. So this angle will be equal to 60 degree. Okay, so from in triangle A prime DB, A prime dp. We can calculate this angle also. Let's say y. Okay, this y will be equal to 180 minus summation of this x and 60 degree. As we have calculated this x at 95, when you will put, you will find that this y comes out to be 25 degree. Okay, now we have all the values of the angle in triangle A prime dv. Okay, now this distance dv is given in the problem as 2.87 meter. Okay, now in the triangle A prime BD, you have all the angles value and you have one edge, then you can easily calculate the uh, mm, other edges dimension. Okay, so in this triangle, what we want to calculate? We want to calculate this length A prime B. Okay, so what we will do? We will apply the sine rule. Okay, so in triangle, let me draw this triangle again. So in this triangle, this is our B point, this is our D point, this is A prime, this angle is X, this angle is Y, this one is 60 degree. This dimension is given as 2.87 degree. Okay, so now when you will apply the sine rule, you can write that this sine of Y. Okay, it will be divided by the uh, edge that is in front of this angle, that is A prime B, equal to this sine x divided by the edge that is in front of this angle, that is BD. Okay, from here you can easily calculate that this A prime B will be comes out to be BD sine y divided by sine x. When you will solve, you will find, sorry, this is not in degree, this is in meter, that is dimension. Okay, so 2.87 sine y value is 25 divided by sine of x, that is 95 degree. Okay, so when you will solve, you will find that this A prime B value comes out to be 1.2175 meter. Okay, now you know the value of this AB, that is the total length of the collector, that is given in the problem as 2.10. You have this value A prime B. Now you can easily calculate this shaded part, that is A prime, that will be equal to the total length of the collector minus this A prime B. The total length of the collector is given as 2.10 meter and you have calculated this A prime B as 1.2175. So after subtracting, this value comes out to be 0. Now let me solve this. I haven't calculated. 2.1 minus 1.2175. Okay. So this value comes out to be 0.8825 meter. In the problem, the fraction of the area has been asked. So fraction will be this A prime divided by the total length of the collector. Okay. So when you will put these values divided by this 2.1, okay, then you will find that it comes out to be 0.42, or in percentage you can say that this 42% of this panel is shaded at the given, for the given profile angle. Okay, so these three problems that we often see in the shaded topic that I have covered. Okay, so this one was the first problem. where you have to where an object comes in between the sun ray and the proposed collector. Then I have solved the second type of problem, that is overhang problem, where the overhang shaded uh, to the window. Okay, then I have shown you the third type of problem, that is the shaded by the preceding arrays of collector to the next row of collector. Okay, so that's all that you will often see in the shaded topic. Okay, now I will discuss that how we can calculate the solar radiation. So this instrument is pyranometer. Okay, the figures have been taken from my lab. Okay, so what this pyranometer calculate? This pyranometer calculates the total irradiance. What does that mean? Total irradiance. Total irradiance meaning the direct radiation plus diffuse radiation plus if there is any reflection from the surrounding. Okay, so this total this pyranometer measures the total irradiance. Okay, so in the figure you have seen that this is our pyranometer. So here is one sensor, the not this one, not this. This is our sensor. Okay, the sunlight and the surroundings radiation falls on this sensor. Then what happens, there is some change in the resistance. Okay, and this resistance calculated through this data logger. Okay, where you will this sensor gives values in voltage. Okay, then using the calibration you can easily calculate the sun solar irradiation. Okay, using calibration between voltage and intensity. Okay, so this is our first instrument that is used to measure the total irradiance. Second one is paralleliometer. This instrument measures the direct or beam radiation. The working of this instrument is similar to the pyranometer, where the radiation falls above on the sensor, and there is some change in the resistance. Then this resistance value is calculated through data logger, where you can uh, calibrate this voltage in terms of direct radiation. Okay, so that's all for today. I have covered the all types of problem that you will see in the shaded topic. Then I have tried to explain some instruments that has been used in the to measure the radiation. Okay, that's all for today. Thank you very much.